Imagine yourselves walking into a room plunged in darkness. You can see a few things, but you know there are more because you keep bumping into them. What do? Well, you reach for the light, of course. Now, what if I told you that your entire life you had been living in such a room? Our universe is composed at 80% of matter that we cannot see. 80% of dark matter. And unfortunately, we cannot simply reach for the light because this dark matter does not emit or reflect or absorb light. We know it exists because it has gravitational effects on regular matter. It is quite literally holding galaxies together. So it's pretty important. But we don't know what it is. It could be exotic particles or tiny black holes or fuzzy waves the size of galaxies. We simply do not know what most of our universe is made of. Now, to solve this fundamental mystery, one of the things that we can do is look at the night sky. And this is what I do with my research. Specifically, I study observations of something named gravitational lenses. Our best theory of gravity predicts that massive objects like galaxies bend the trajectory of light rays passing nearby. So the light from a distant source can get distorted and magnified, sometimes showing up multiple times in our observations. We call this gravitational lensing. And because it is a gravitational effect, dark matter plays a major role, which offers a unique way of probing its properties. Think of a magnifying glass that you would hold over a text. If you notice that one of the letters is slightly deformed, maybe more magnified than what you expect, then naturally you would infer the presence of a dent or a bump in the glass. And then by running your magnifying glass over the entire text, you would start to build an idea of how many bumps and dents there are overall. That is the same idea for my research. Anomalies in a strongly lensed image tell us that a dark matter clump is nearby. And then by looking at many images, we can start to have an idea of how dark matter behaves in general, whether it is smooth or clumpy, warm or cold, hyper-concentrated or fuzzy. Now, we have to be careful. Some of the anomalies are not caused by dark matter itself, and we don't want to be finding bumps and dents that don't exist. So what I spend most of my time on is improving our models and our measurements to make sure that we're not misled. So that with these efforts, with time, with more observations, there's hope to finally shine a light on dark matter. Because until we do, we'll be left wandering in a dark room, and 80% of the universe will remain a mystery. Thank you.